Okay. Right. Good evening. What about my audio? Am I audible? What about my audio? Am I audible? Okay. Right. Give me 1 second. Okay. All right. Yeah, I think for most of the areas it's raining heavily today. So sometimes there might be delays of the students when joining. Right. Anyway, since this session is anyway streamed on YouTube, we'll start the discussion. So if anyone joins late, they can go to the YouTube and watch the recording as well. Right. Okay. And now today, this week, we are exactly 5 weeks ahead of the exam. Right. Exactly 5 weeks. And this week is also gone. Right. Exact 5 weeks. Exactly 5 weeks. Now, if you count the number of days, it's like 36 days or something like that. Right. Yeah, it's 36 days. Okay. Right. Question one. Question one. What is the unit of moment of force? Very straightforward. Question one. What is the unit of moment of force? Very straightforward. Moment of force is, we know, F times D. Moment of force is force times perpendicular distance. Right? So the unit of force moment is force is measured in newtons. Perpendicular distance is measured in meters, Newton meters. Right? Newton meters, answer 4. For first one, answer 4. For first one, answer 4. Okay. Second one. Which of the two set given below are same in dimensions? Right. Now, about this quantity is given, you have to know dimensions of all of them. Right. You have to know dimensions of all of them by now. Right. There cannot be any physical quantities that you don't know dimensions of. Right. First one, surface tension and pressure. 2. First one, surface tension and pressure. Dimension of surface tension is mt minus 2. Right. Now you have to know these dimensions. Dimension of surface tension is mt minus 2. and dimensions of pressure is pressure is F over, right? So that is ml minus 1 t minus 2. Then second one, relative density and relative velocity. For relative density, no dimensions. Relative velocity, it has a dimension of velocity. Relative density is a velocity. Sorry, relative velocity is a velocity. Relative density is a ratio. Because relative density means density of an object or density of water. It is called the relative density, dimensionless. And relative velocity is a difference, or in other words, a subtraction or an addition of velocities. So therefore, relative velocity has the same dimensions of velocity. Then work and torque. Work and torque. Work is F times D, right? F times D, which means there is ml squared t minus 2. And torque is also force moment. Torque is a force moment. Force moment is again F times D, same. So that is ml squared t minus 2. This is correct. And the others, change of momentum. Change of momentum is a momentum. Momentum is ml t minus 1. Force is ml t minus 2. And power and efficiency. Power means energy over time. Right? Power is energy over time, which means energy is ml squared t minus 2, no? So energy over time means t minus 3. And efficiency is a percentage. Efficiency means any output over input into 100% is called efficiency, right? Then output will be measured in the same measurement, and input is also taken in the same measurement, and the percentage, that's a percentage value. Percentage value means that's a value ratio, right? No dimensions. So answer is 3. For 2, answer 3. Answer 3. Question 3. Question 3. The diagram shows a micrometer screw gauge with 1 millimeter pitch. The jaws are coincided. The drum of the micrometer is divided into 50 equal parts. Which statement below is true? Which statement below is true? Right. 3. So first thing, if you don't know the least count of the instrument, first you can determine the least count of the instrument. Right. So if you don't know the least count, we know least count is pitch. Pitch is 1 millimeter given. Right. So the pitch is given 1 millimeter over number of divisions on vernier scale, which means 50. Right? So which means here there is 1 over 50. 1 over 50 means 0.02 millimeters. Right? Now in this micrometer screw gauge given, right? In this micrometer screw gauge given, specific one given, the least count is different from what we know, because in the regular one we know the least count is 0.01, because it is in the divisions of half millimeters. This is 1 millimeter. The diagram shows a micrometer screw gauge with a 1 millimeter pitch. So here pitch is 1 millimeter. That's a different one. That's a different one. This is different to the typical micrometer screw gauge you are dealing with, right? So for this one, new least count is this. Then about the zero error, if 0 is above the center line, there is a negative 0 error. If 0 is above the center line, there is a negative 0 error. Negative 0 error. Negative 0 error is read as total divisions minus number of coincided divisions. Number of coincided divisions means 48, 45, 46, 47, 48. Right? 48 into least count 0.02. 2 times this thing means 0.04 millimeters. Right? Now the error is 0.04 millimeters. That's a negative error. If there is a negative error, a positive correction should be done. If there is a negative error, positive correction should be done, which means it should be added. Should be added. Then the answer is 0 error is 0.04. Only one answer. Eh? The 0 error is 0.04 and error should be added to the measurement. Answer 5. For 3, answer 5. Right? Next. Question 4. Okay. So the height of a storied building with ground floor, first floor, second floor, and third floor are 5 meters, right? Which means 5 meters each. You better add this. Make that correction. It should be the height of the storied building with ground floor, first floor, second floor, and third floor are each 5 meters, right? Are each 5 meters. What is the time interval for a falling tile from the third floor? A part is missing in the question. It should be like this. What is the time interval for a falling tile from third floor to pass first floor? To pass first floor. That part should be added. Right? What is the time interval for a falling tile from third floor to pass first floor? To pass first floor. Okay, now it is like this. It's a building with 4 floors then altogether. Right? Something like this. Right? Ground, first floor, second floor, and third floor. Ground, first, second, third. Right? So each is 5 meters height, which means this is 20 meters. This is 20 meters in height. Right? Then, what is the time interval for a falling tile from third floor to pass first floor? To pass first floor, which means we need the time taken to pass this. We need the time taken to pass this first floor. Right? I'll do this way. Now the tile is, if this is the tile is falling from rest. Right? Then first we can apply an equation up to this level and we can find the distance, find the time taken up to this point. See? Then S equals UD plus half AD squared for first two, which means until it falls 10 meters. U is 0, which means half G is plus 10. Let's say T is T1 squared. 10 to 10 cancels. 2 equals T1. So T1 equals root 2 seconds. And then if I apply another equation up to this point, then we will get the total time until it finish passing the first floor. Right? Then downwards, S equals UD plus half AD squared. S will be 15. 15 equals half 10 T squared. Right? So by 5 this cancels. 5 times 3, 5 times 2. 2 to 2 cancels, which means let's say this T2. T2 equals T2 squared equals 3. T2 equals root 3 seconds. Right? Okay. Now the answer is here. The time taken to pass. Therefore, time taken to pass this thing is, right? Time taken to pass this thing means root 3 minus root 2. Right? Because it takes root 3 seconds to reach this point, which means to completely pass first floor, right? And until it starts passing first floor, until it completes first 2 floors, it takes only root 2 seconds, right? Then the time takes in between means root 3 minus root 2. Root 3 minus root 2, answer 4. For 4, answer 4. Answer 4. right? Then 5. 5. The diagram shows the distance time graph for a moving object. Which statement is most suitable? Right. ST. ST is given. Right. Which statement is most suitable? Okay. A motion with uniform velocity, a motion with uniform acceleration. Okay. Now, to check on that, we know this is ST graph. So gradient of ST represents velocity. Gradient of ST represents velocity. Right? Then if there is a uniform velocity, gradient should be uniform. If there is an acceleration, velocity should be increasing, which means gradient should be increasing. So this is actually an increasing gradient. This is a positively increasing gradient, which means this is an acceleration. So here gradient increases. In this case, gradient increases, which means velocity increases. Velocity increasing velocity means there is an acceleration, right? So one thing is decided. This is an object moving with an acceleration. Then you have two answers. Answer 2 or answer 5. Sorry, 3 answers. Answer 2, you have accelerations. Answer 3, it's also about an acceleration. Answer 5 also about an acceleration. Right. Then it says acceleration and starting from rest and starting with initial velocity. Right. If you need to check the initial point, check the initial gradient. If you need to check the initial velocity, check the initial gradient. Initial gradient is here. See? So initial gradient is non-zero. Initial gradient is non-zero, which means initial velocity is non-zero. Initial gradient is non-zero. If the initial gradient is 0, it should be touching x-axis because horizontal lines are the zero gradients. Horizontal lines are the zero gradients. So this is not a zero gradient. This is not a zero gradient, which means it has an initial velocity. So it's a motion in acceleration with an initial velocity. Answer 5. Answer 5. Right? 6. 6. The diagram shows two hammers which are equal in shape. Handles of hammer P made up of metal and handle of hammer Q is wood. Right. One is metal and one is wood. Mass of two hammers is equal. Out of the given statements, which statement shows the correct hammer and the place that it should be held when hammering a nail? Okay. Hammer suitable for use. Okay. Now this is the idea. When we are using a hammer, so we know principle behind the hammer is force moment. Principle behind the hammer is force moment, right? Because this is how we hammer using a hammer, right? So if the center of gravity of the hammer is away from the holding point, which means we can create a more force moment like this. If the center of gravity of the hammer, if this is the hammer, right? Now, if the center of gravity of hammer is more away from the holding point, which means you can create more force moment. You can get more force moment. Creating more force moment easily means easily we can hammer a nail, right? So therefore, always center of gravity of the hammer should always be away as much as possible. It should be away. It should be away as much as possible. Should be away. Then compared to the metal one, wooden handle should be less in weight compared to the metal. So therefore, center of gravity is far away in the wooden one. Therefore, suitable hammer is Q. Suitable hammer is Q. Suitable hammer is Q. Alright? Because center of gravity should be away as much as possible to create the force moment easily. To create a required force moment easily. Because force moment is force into D. This force is constant anyway. In both hammers, it says masses are same. Since masses are same, this is same. Right? Since masses are same, this is same. Then to create the force moment, perpendicular distance should be higher. Higher perpendicular distance is coming if the center of gravity is away, which means hammer Q is suitable. And then place where the hammer should be held. Okay, again, our target is, when hammering something, our target is having a higher force moment, creating a higher force moment. So it should be held at the furthest point as the distance is higher, because our purpose is increasing this distance, right? So it should be held at not A, it should be held at B. Should be held at B. Like this. Should be held at B. Right? Q and B. Q and B, answer 5. For 6, answer 5. Q and B. Right? Right, 7. Arguments are clear, right? About the hammer case. Because once you have a higher force moment, which means easily it can be hammered. Higher force moment means easily it can be hammered. Higher force moment is created itself by the weight itself. Right? Created by the weight itself. Then the external force that we need to apply is lesser in that kind of hammer. Right? Okay. 7. The figure shows 5 forces in one plane act on a particle at point A. The direction of motion and the resultant force of the particle is, right, direction of motion and the resultant force on the particle. Right. See. Seven. 12√3 in this direction. 12√3 and 5 and 5, 30 and 30. 5 newtons with 30 and 5 newtons here again with 30. 16 newtons with 30 again. 16 newtons with 30 here. Right. So no forces at these two. 1, 2, 3, 4, downwards 8 newtons. Downwards 8 newtons. Okay. Then we need the resultant of, right? Easiest way is you can dissolve these forces in horizontal and vertical directions. Dissolve these forces in horizontal and vertical directions. Right, that's it. Then here, see, I'll be dissolving at once. Dissolved component of this here comes in this direction is 5 sine 30. 5 sine 30. And from here also another 5 sine 30 comes. Which means that 5 sine 30 to 5 sine 30 cancels each other. Right? So likewise, now you have to see cancelling forces at once. You have to see cancelling forces at once. 5 sine 30 comes here, 5 sine 30 comes here, cancels each other. Right. Now from this, 16 sine 30 comes. 16 sine 30 is 8. Which means that 16 sine 30 cancels with this 8 newtons. Right? So it's cancelled. And from here, only 16 cos 30 remains. Only 16 cos 30 remains. Right? And from these two, we know 5 cos 30 and 5 cos 30 remains. Right? From these two, 2 times 5 cos 30 remains. Okay. Now, you can dissolve them. 5 cos 30, 2 times 5 cos 30, which means 5 root 3, no? Because cos 30 is root 3 over 2. This is 2 times 5 times root 3 over 2. 2 to 2 cancels. So that is 5 root 3. Right? And 16 cos 30 means 8 root 3. 8 root 3. Right? Then in this direction we have 12 plus 5, 17 root 3. So the resultant is 17 root 3 minus this 8 root 3. That is 9 root 3. Resultant is 9 root 3. Right? There's only one answer with 9 root 3. Direction AP. Correct, no? Yeah. AP 9 root 3. 7 answer 1. So 7 answer 1. Right. If you found the magnitude, right, you don't have any selections, options, only one answer is given. Right? If you know the correct magnitude. Only one answer is given if you know the correct magnitude. Right. 8. The diagram shows mass capital M tied with a string which runs over a smooth fixed pulley at the upper end of a rough inclined plane. A mass simple M tied at the free end of the string. String. Initially, the system is at rest, but when the angle of the inclined plane theta gradually increases at theta equals 60, the mass M starts to slip down along the inclined plane. Start to slip means that has reached the limiting point. That is at the limiting friction or the limiting point. Right? Then if the friction of, it should be coefficient of friction, right? That's a typo. If the coefficient of friction between M and inclined plane is 1 over root 3, the ratio of M over M is, okay, 8. Now this theta is at 60. Theta is at 60. Capital M and simple M. So this is simple mg. This is capital Mg. Right? So at 60, it just start to slip. Right? So which means a moment before 60, which means that is at rest. A moment before 60, that is at rest. Right? So we are going to do the calculation for that point. Right? A very moment before 60. It is very approximately equal to 60. So therefore, we have to consider it as 60 and do the calculation. Right. Then here, tension acts T, same string, same tension. Right. Then when this tries to move, is it moving downwards or upwards? Mass M starts to slip down. Right. So which means it is going to move downwards. it is going to move downwards. Therefore, friction will be acting upwards. Right? Friction will be acting upwards. Okay, here, if you identify the dissolved components, we have a resultant here, sorry, reaction here, 60, and this is mg cos 60, and this will be mg sin 60. Right? Now, consider the equilibrium. Consider the equilibrium. From vertical equilibrium of this thing, simple length, you can say vertical equilibrium of simple length. T equals simple mg. T equals simple mg. And then inclined equilibrium. Inclined equilibrium for the inclined plane for capital M, mg sin d, right, sin 60. Mg sin 60 equals upwards T plus F. Right? Simplify this. Then mg sin 60 is root 3 over 2. And for T, you can write simple mg plus F. We know F is mu r. F can be written as mu r. Mu r. Right? Mu is given 1 over root 3. 1 over root 3. 1 over root 3. Now about r, we know this is in an equilibrium perpendicular to the plane. See? This is in an equilibrium perpendicular to the plane, which means r equals mg cos 60. So r is mg cos 60, capital Mg cos 60. Cos 60 is half. Right? Okay, now it's a simplification. It's a simplification. G cancels throughout. G to G cancels. This side, this is root 3 capital M over 2. You can take this to the other side, which means minus capital M over 2 root 3. Capital M over 2 root 3. Right? Okay. Then this equals simple mg. This equals simple mg. Right. So apply the common denominator. Apply a common denominator. First, I'm going to take m out while applying the common denominator. Common denominator is 2 root 3. Common denominator is 2 root 3. Then this should be multiplied with a root 3, which means 3 remains. Right? 2 root 3 here, which means minus 1 remains. 2 root 3 is already there. No? Times m is taken out, m. Sorry, g is cancelled. G is cancelled. Simple m. Right? What we need? Capital M O simple M. Capital M O simple M. Right? Okay. 3 minus 1 means 2. Then create capital M O simple M here itself. Capital M O simple M. This can be multiplied to the other side. Then 2 root 3 over 3 minus 1 means 2. 2 cancels. So that is root 3. Root 3 answer 2. 4 8 answer 2. If you understand the question and do the calculation properly, right, the correct answers are coming. That's actually an equilibrium, right? Even though it says about a sliding, right? We are considering the equilibrium point and doing the calculation. We are considering the equilibrium point and doing the calculation. Right? Next. 9. Fine. A sunspot placed on a certain pinhole camera made by a student takes 5 minutes to move from one point to the other. Okay. A sun hole in a pinhole camera, right? So which means takes 5 minutes. Okay, something like this. It's something like this. So it takes 5 minutes to move from one point to the other, right? Because we know sun is doing a rotational motion, right? We don't know what this angle is, right? So whatever the angle it is, it takes 5 minutes, right? For that scenario, if I apply omega equals theta over t, right? So we know since periodic time of sun is known as 24 hours, we can expand omega as 2 phi over t, right? Using periodic time. 2 phi over t, omega is 2 phi over t. 2 phi over t equals theta over simple t, right? Then 2 phi over capital T is 24 hours, right? I will convert this to minutes because this side is given in minutes. Then 24 into 60, right? We don't know what theta is. That over t 5 minutes. T is 5 minutes. 5, right? Then cancel these cancelling terms. 5 and 60 cancels, 12 here, right? And 2 and 24 cancels, 12 here. Okay, so theta comes. Theta equals 5 over 12 times 12. We'll keep like this. Theta equals 5 over 12 times 12. Right. Now, it says an image of moving motor car on a racetrack takes 1.56 seconds to move between the same 2 points of the same camera screen. Right. To move between same 2 points, which means that is also to cover the same angle. That is also to cover the same angle. Takes 1.56 seconds. Once you see 1.56 and it's asked about an approximate value, 1.56 when it's observed through the stage at the center of the racetrack with the radius 500 meters, then the speed of motor car approximately, right? Then once you see a number like 1.56, right, you should have an idea that now here also we have got 5. Actually 1.57 means 5 over 2. 3.14, 5 is 3.14, no? Right? 3.14 over 2 is 1.57, right? So which means 1.56 is a close value for 5 over 2, right? Since 5 is already here, now we can think of something that cancels with 5 there if I use 5 over 2 instead of 1.56, right? So having that idea in mind, we'll go to the calculation. Then it takes 1.56 seconds. Okay. To go between same 2 points, which means to cover the same angle. That is to cover the same angle, right? Then again, we can use this omega equals, we know, theta over t. This is for car now. But now omega can be expanded as VOR. VOR is theta over t, right? V is what we need. R is 500, right? Theta is here. 5 over 12 times 12. And t, instead of writing 1.56, we know 1.56 is approximately 5 over 2. 1.56 is approximately 5 over 2. Then t here is 5 over 2, that 2 comes here, right? So 5 to 5 cancels. What else cancels? 2 to 12 cancels, 6, right? Okay, then V equals, there are more cancelling terms, V equals 500 over 12 times 6. By 4, this can be cancelled. No? By 4, right? By 4, this can be cancelled. This is 4 times 3 and this is 4 times 125. Okay, that's all. So the final answer 125 over 3 times 6, 80. I have to get this ratio, get this value. 125 over 80. Find that value. 125 over 80. It comes to 6.94. It comes to 6.94 ms minus 1. So the approximate value is 7. 6.94. Approximately 7. For 9, answer 1. Right? A little bit different question. A little bit different question. Right? About a hint about the motion of sun is given. I had to use periodic time of sun for this calculation. Right? So that's something coming from the general knowledge and the common sense. Right? Take it down. Then 10. What is the maximum angular velocity of a rotating plate with 20 centimeters radius that the objects on the plate are not moved away when it rotates around its axis, its axle? The coefficient of friction between plate and the object on it is half. Okay, something like this. This is a plate of radius 20 centimeters. Plate of radius 20 centimeters. Right? Objects on the plate. Maximum angular velocity. Okay. Then to have the maximum angular velocity, object should be here. So we know when it rotates in a rotational motion or a circular motion, right? Actually, the disk is it a disk? Plate, right? When the plate is rotating in rotational motion, this object actually rotates in a circular motion because it travels in a circle, right? So it travels in a circular motion. Circular motion. So we know when it travels in a circular motion, always a centrifugal force exerts. A centrifugal force exerts. Direction of centrifugal force is away from center. Direction of centrifugal force is away from center. Right? Centrifugal force. To counterbalance it, friction should be here towards the center. To counterbalance centrifugal force, friction should be towards center. Right? Then, so balance these two. Balance these two because it says are not moved away, right? Then it should be at rest like this. F equals Fc, which means F equals Fc. F is mu r. F is mu r. And centrifugal force can be written as mr omega squared. Centrifugal force can be written as mr omega squared. Mu is given half and r is mg, right? Reaction. R is given 20, but that is in centimeters. Then 20 times 10 to the power minus 2 into omega squared. M to M cancels, right? This G to 110 can be cancelled from here. G cancel kara 10 na kek. Right. Then what else remaining? Omega squared equals we can take this to the other side. Then it becomes 100. Then 2 and 2 means 4. 100 over 4. So omega squared equals 25. Omega equals 5. Omega equals 5. Answer 5. For 10, answer 5. Right. Eleven. 11. What is the maximum velocity of a car with 90 kilowatts power and 500 kilograms mass when it climbs a hill with an inclination of 13 to 5? Coefficient of friction of the road is 1 over 3. Right. Now, there is another way of giving angles. In previous papers also we have met such cases. Right. So, I think in like in a paper we had like 3 or 4 weeks back. Right. I think 3 weeks back or something like that. As I can remember, there was a question with the same type of angle. If the angle is given in that way, it refers to this. It refers to this. If the angle is given like that, right, which means it refers to 13 to 5 means when it moves 13 along the plane, right, it goes 5 vertically upwards, which means when it travels 13 meters along the plane, it lifts up by 5 meters, right? If that is in kilometers, 13, 5, because it should be in same units. If that is 5 centimeters, 13 centimeters, 5 centimeters. So likewise, that's a ratio, no? That's a ratio. So whatever the measurement, whatever the unit you are using to measure length doesn't matter, that's a ratio. Then if it moves 13 from this, it moves 5 upwards like this, right? 13 to 5. That is one way of giving angles. That is one way of giving angles. And once we saw 5 and 13, right? So you have to understand that this is a Pythagoras combination. This is a Pythagoras combination. 5, 13 means this has to be 12, right? Now, which means sin theta and cos theta are known. Now, from this, sin theta means 5 over 13, right? And cos theta is 12 over 13, right? So, having that in hand, go to question. What's the maximum velocity of the car with 90 kilowatts power and 500 kilograms mass when it climb a hill with an inclination right? Okay, then force should be determined. Force එක හොයාගන්න පුළුවන් මෙතනින්. We know this is 5,000 newtons then. 5,000 newtons. And the friction is also given, right? Yeah. So when it travels upwards with V, friction acts downwards. A reaction is there. And here we know this is 5,000. If this is theta, this is theta. 5,000 cos theta. And towards this side, this comes 5,000 sin theta components. 5,000 cos theta and 5,000 sin theta. Right? Then the minimum force required for the motion is, minimum force means is the repulsion force, the force given by the engine, right? Propulsion force, not the repulsion. Propulsion force, propulsion. The force given by the engine, right? So minimum F should be, so we know minimum F should be 500 sin theta, 5,000 sin theta plus F, right? So F equals here 5,000 sin theta means 5 over 13 plus F is mu r. Mu is given half. mu is given half. Sorry, 1 over 3. Mu is 1 over 3. R, again, we know R equals 5000 cos theta. 5000 cos theta, 12 over 30. Right. So this thing cancels 3 times, 4 here. So F equals, finding F equals, so we can see 5000 over 13 is common, no? 5000 over 13 is common. Then here 5 plus 4 remains, right? Which means 9. 5 plus 4 remains 9. Okay, now we can apply P equals Fe. If that is moving upwards, so upwards plane, apply P equals Fe. Power equals force into velocity. Power is given. Power 90 kilowatts. 90 kilo, 10 to the power 3. F is here. 5000 over 13. 5000 over 13 times 9 times V. Right? Okay, then this 9 to 90 to 90 में cancel करूँ 10 to the power 3 to 10 to the power 3 cancels. Then 9 to 90 cancels 10. Right? Then 10 and 5 also cancels. 5 times 2. So V comes as 13 times 2, 26. V 26. It's the answer 3. For 11, answer 3. 26. Right. That's again not a common question that every day comes, right? But that is not an new question as well. So once in a while, those kind of questions are also coming. Like once in a while. 12. 12. A spiral spring with a spring constant K compressed to distance x and placed a mass simple m on it and released. The maximum velocity gained by the mass is, okay, something like this. The spring is, let's say natural length of the spring is here, and now the spring is compressed like this. Spring is compressed and the mass is kept. This compressed length is x, right? Spiral spring with spring constant K compressed to distance x and placed a mass m on it and released. The maximum velocity gained by the mass is, right? And easiest way is applying energy. Easiest way is applying energy, right? Easiest way is applying energy. Then total energy at this point equals total energy at this point, no? Let's say A and B. Then total energy at A equals total energy at B. Total energy at A equals total energy at B. Total energy at A. We'll consider this as Earth zero level, right? Maximum velocity gained by the mass is, okay. Then we have this kind of an argument. If we need the maximum velocity gained by the ball, maximum velocity is at the release point. Maximum velocity is at the release point, right? So which means at once we can equate these two without using B, because at B, that is not the maximum velocity. Maximum velocity is at the release point. Maximum velocity will be at the release point. Release point is here. Then directly, this whole energy that is stored on the object, on the spring, should be converted into kinetic energy. So simply half kx squared equals half mv squared. Half kx squared equals half mv squared. Half to half cancels. Right? Then we need velocity, right? Velocity. Okay, then v squared equals kx squared over m. V equals root kx squared over m. Right? So x squared can be taken out if needed. Okay, it's not taken out. Kx squared over m is given. Answer 3. 12 to 3. Right? For 12, answer 3. 13. 13 will do here. The diagram shows a solid wooden cylinder with a uniform cross-sectional area floating 3/4 of its volume immersed in water and 1/4 immersed in an oil with density 800. Right. If the density of water is 1000, the density of wood is. Okay. So it is like this. Okay, something like this. Right. 3/4 is immersed here, which means if the volume is V, 3VO4 is here, and only VO4 is here. This is density 800 oil. This is 1000. Right. So we know from oil there will be an upthrust creates, let's say U1, and from water also there will be an upthrust creates, let's say U2. And this weight is balanced by both upthrust forces. The weight is balanced by the contribution of both upthrusts. Right? So if there is in equilibrium, then we can consider vertical equilibrium. That is in equilibrium. That floats. Floating means there is an equilibrium. Right? Not droning, not moving upwards, that is an equilibrium. Floating is an equilibrium. Then vertical upwards forces equals vertical downward forces. U1 plus U2 equals mg. U1 plus U2 equals mg. U1, we know U is V rho g. Very popular equation, U is V rho g. Then U1, the respective immersed volume is VO4, only VO4. VO4 rho 800, G cancels, no? So I'm not going to write G. Plus, this is 3VO4, 1000. G cancels. And here M remains. M remains. Right? Then, what comes here? 300V. 4 times 200, no? Sorry, 200V. 200V. Plus here, 4 times, cancel it on 4 times 200. This is 4 times 250. Then 750V. Right? 750V equals, we know M can be written as V rho again. Total volume times density. Mass is a popular equation. Mass is V rho. Mass can be written as V rho. Then V2 V cancels. Which means 200 plus 750, 950. 950 equals rho. 950. Answer 5. For 13, answer 5. Okay. Right. 14. 14. 14. With considering the R resistance, velocity time graph of a ball dropped freely from a place vertically up to a horizontal table and bounce with non-elastic collisions. Non-elastic means there is an energy loss. If there is an elastic collision, there is no energy loss. If there is non-elastic means non-elastic, it is also called inelastic. Inelastic, right? For inelastic collisions, there is an energy loss, right? Okay, then we know if there is falling downwards, if there is a release from a point, right? So initially it increases velocity and comes to the horizontal surface. And once it hits with the horizontal surface, there will be an energy loss, right? Then it is not going to return back to the same initial point, right? It will return to somewhere less than that, some point less than that in height, right? So therefore, it keeps losing energy. It keeps losing energy. And even though it's moving upwards or downwards, only acceleration acts on the object is gravitational acceleration. Only acceleration acts on the object is gravitational acceleration. If there is moving downwards, that will be a deceleration, but still downwards, what we have is gravitational acceleration. So therefore, acceleration should be same. Since accelerations are same, we know acceleration is given by gradient of Vt, no? Right? Acceleration is given by gradient of Vt is A. So therefore, since acceleration is constant, this is G actually. But since acceleration is constant, gradient should be constant. Gradient should be constant throughout, right? And we know direction of motion changes. When direction of motion changes, the vector should be plus and minus. It changes signs when the direction changes, right? So vector should be in both plus and minus sides of the graph. So therefore 2 is wrong anyway. 2 is wrong. And since acceleration is same, gradient throughout the curve should be same. So therefore, in third one, gradients are different. In fifth one also, gradients are different, right? In 1 and 4, gradients are same. But we know there is an energy loss. Due to each bounce, there is an energy loss. So with that energy loss, velocity decreases and the height it reaches decreases. So therefore, that height should be decreasing. Height and velocity should be decreasing over time. Answer is 4. Answer 4. Right? For 14, answer 4. So if you got any questions, you can always ask anything, right? If you have any questions regarding Any of the questions we discussed now, right? Or any other subject related matters, you can always ask anything, right? So I'm more than happy to answer all of your questions, all your questions. Sanesha, you are joining today, right? Or have you joined to the class before? You are joining today? Right. 15. The diagram shows the shape of water wave that transmitted along the water surface from part A of a pond to part B, which is the correct statement. Which is the correct statement, right? Now, in part A and part B, what we can clearly see is lambda has changed, right? What we can clearly see is lambda has changed. Lambda is changed. And amplitude is also changed, right? Lambda and amplitude change, right? Okay, the other thing is now about depth and about depth questions are there, and about frequency. The other thing is when the medium changes of a wave, frequency remains unchanged. That is a very special feature about a wave, right? Even though all other parameters changes, frequency is the only parameter which remains unchanged of the wave. So therefore, frequency remains unchanged, right? So the answers with frequency increased, so something like that. Frequency is high, something like that. Frequency is unchanged, right? About lambda, we can argue. For water waves, we know, right? The equation is V equals root GH. For water waves, we know V can be written as F lambda. So F lambda is root GH. F lambda is root GH. Right? F lambda equals root GH. G is a constant. F is a constant, I told you. Then when H increases, lambda increases. When H increases, lambda increases. Right? Now, clearly we can see lambda of part A is higher because lambda is the distance, shortest distance between same phase, 2 points at same phase of the wave, like this. This is called lambda of the wave. This is the lambda of the wave. Shortest distance between 2 points at the same phase. Right? Now, if I compare A and B, right? If I compare A and B, lambda in part A is greater than lambda in part B. Lambda in part A is greater than lambda in part B. Right? Lambda in part A is greater than lambda in part B. Then, if lambda in A is higher, see, what's my thought? Lambda A is greater than lambda B, which means the depth, height of the medium A should be greater than height of medium B. Height of medium A should be greater than height of medium B. Right? Okay, then statement 1, the depth of water at part B is lesser than part A. The frequency of the wave is increased strong because frequency is constant. Second one, the depth of water at part B is higher. No, part A is higher. That is also wrong. The depth of water at part B is lesser. Part B is lesser. That is correct. Third one, depth of water in part B is lesser than part A. Energy of the wave is increased. No. Energy is same. Energy is same. Right? Energy should be same. Energy should be same. Energy is same. Then 4, the velocity of the wave of part B is less than at part A. The frequency is I know because frequency is unchanged. 5, the velocity of the wave at part B is less. About velocity, you can argue from here. Right? About velocity, you can argue from here. V equals F lambda. F is a constant. Right? Then higher V means higher lambda. Higher lambda is at A, no? Higher lambda is at A, which means higher velocity is also at A and lesser velocity is at B. The velocity of the wave at part B is less than part A. That is correct. Right? And frequency is not changed. That is also correct. Answer 5. For 15, answer 5. For 15, answer 5. 16. Right. Take it down. Right. Take it down. Give me 2 minutes until I add some ink for the marker. right? Okay, then 16. The graph represents the variation of distance against the time of a particle in a simple harmonic motion. The ratio of the potential energy related to locations of particle would be doubled when there's a small typo again. It should be corrected as the ratio of the kinetic energy. Right? Please make that correction. It should be the ratio of the kinetic energy. E. It should be ratio of the kinetic energy. Ratio of the kinetic energy E. Kinetic energy E. Right? Okay. So we know at the center kinetic energy is maximum in a simple harmonic motion. Right? Kinetic energy is maximum at the center of the simple harmonic motion. Right? So kinetic energy is maximum at center. Right? And we know kinetic energy is 0 at amplitude. Kinetic energy is 0 at amplitude. Then in a point in between, kinetic energy will be half of that value as well, because when it changes from a center to amplitude, kinetic energy changes from the maximum value to the 0. Kinetic energy changes from maximum value to the 0, right? So if the motion starts from the center like this, right? So like this, when it starts from center, kinetic energy is maximum, and at the amplitude, kinetic energy is 0. So therefore, in between, kinetic energy is decreasing now. So which means in between it can reach the half, right? So therefore, my target is, now we need the location support particle for the ratio to be doubled, right? Doubled in a ratio, right? Then with the center, because at the center there is maximum, with the center, if we take another middle point, then it can be doubled as well, right? Now the only center point given here is C, no? Yeah, only center point given here is C. Then with C and D is okay, or C and A is also okay, right? There are two answers in that case. There are two answers given mistakenly. Yeah, it should be either EC over ED or EC over EA. Both are correct. Both are correct. Two answers are correct there, right? So it is either EC over EA or EC over ED. Both are correct. D is about. Oh, wait. No. There are no two answers, because D is close to the peak. D is close to peak, which means that is less than half. Right? That is less than half. So therefore only this is coming. EC over EA is coming. EC over EA. Because A is at the middle. A is at the middle. EC over EA. EC over EA means answer 2. For 16, answer 2. Right? For 16, answer 2. Okay, 17. You have given 5 tuning forks of frequency 270, 272, 270 hertz. Then 272 hertz. Then 274, 81, 274 hertz, 281 hertz. 286 hertz. 286 hertz. Right. Now, the question is number of ways of selecting these tuning forks to hear beats when vibrating is. Right. To hear beats when vibrating is. Right. So one thing about human ear is, right, if we are to hear beats, right, the minimum number of beats we can, maximum number of beats we can hear is 10. Maximum number of beats we can hear is 10, right? Maximum number is 10 because minimum time difference we can have for the human ear is 0.1 seconds, 0.1 seconds, 0.1. Then respective frequency is 10, right? So beats can 10 විතරයි අහන්න පුළුවන්. If the difference is, we know beats means difference between frequencies, no? That you know, no? Beats means beats means difference of frequencies, right? But this difference should be less than 10. This difference should be less than 10 hertz in order to hear by a human ear, right? In order to hear by a human ear, it should be less than 10. Then select the ways or count the ways that you can choose any two tuning forks from here as the difference is less than 10. That's the argument here, right? That's the argument. Okay. Right. Okay, now see, we can do 270 with 272. Difference is 274. But we can't consider 270 with 281 because the difference is going to be 11, no? That is less than 10, greater than 10, right? Then what about 272? 272 can be vibrated with, right, 274. And 272 can be vibrated with 281. Can be vibrated with 281 because the difference is only 9, right? Then 274 with 81 is also possible, no? 274 with 81, difference is only 7. And 274 and 86 cannot be done, but 81 with 86 can be done. Then how many ways? 1, 2, 3, 4, 5, 6. Altogether 6 ways. 6 ways. Answer is 6. For 17, answer 6, 3. For 17, answer 3. For 17, answer 3. For 17, answer 3. 6 ways. 6 ways. right? 18, again a calculation. The minimum frequency necessary for resonance is 320 Hz when vibrating tuning fork is held over the one end of an open pipe with 50 centimeters long. One end open pipe, 50 centimeters long. Right, 18. Something like this. One end open pipe, 50 centimeters long. Right, one end open, 50 centimeters long. The minimum frequency necessary for resonance is 320, which means this tuning fork here should be 320 Hertz. Right, it should be 320 Hertz. Then minimum frequency, no, which means this is at the fundamental pattern, right? Pattern fundamental. That is at the fundamental pattern, right? Then the minimum frequency of the tuning fork resonance is the minimum frequency of the resonance of the tuning fork is 163 Hertz after one end of the pipe is closed. After one end of the pipe is closed. First one is an open pipe. One end of an open pipe. Sorry. Okay. Then this is an open pipe. Sorry. This is an open pipe. Then fundamental frequency is like this. There is an open pipe. And now one end of the pipe is closed. Now the fundamental frequency is this. Right? And it is 163 now. Now here, this is 163 Hertz. Still, this is 50 centimeters long. Still 50 centimeters long. Right? According to this, the end correction of the pipe and the velocity of sound in air is end correction and velocity of sound in air. Right. So let's consider end correction here as E. E. So here also we have an end correction E. Here we have one end correction E. Right. Okay. Then first we can write lambda. You can write lambda here. This is lambda of 4 parts. No. Lambda of 4 times such 2 parts equals L plus 2E, which means 50 plus 2E. Right. Then lambda equals 2 times 50 plus 2E. Right. Then if we use V equals F lambda, now we know V remains same, no? Right? V remains same because V is gamma RT over M. V of a tube is gamma RT over M. If temperature remains same, if molar mass remains same, which means V is same. Right? Now in this case, V should be F is 320 times lambda 2 times 50 plus 2E. Right? So keep it as it is, and then lambda here is lambda over 4 times only 1 equals L is 50 plus E again. Right? Now this lambda is 4 times, let's say this is lambda 1. Right? And this is lambda 2. 4 times 50 plus E. 4 times 50 plus E. Right? Then V equals F lambda again. F is 163 and lambda is 4 times 50 plus E. Right? Okay, then E can be determined if these two are equivalent, equation 1 and 2. Right? Then 320 times 2 times 50 plus 2e equals 163 times 4 times 50 plus e. Right? So simplify this. Simplify. This is 2 times 2. And by 2 this cancels. 2 times this is 160. Right? Then this side 160 times 50 comes. Plus here 160 times 2 times e comes. 160 times 2e comes. And the other side 163 times 50 comes. Plus here 163 times e comes. Right? Then this 160 times 50, this 163 times 50, which means here 3 times 50 remains. Right? And here 160 times 2e, this is 163 times e. Right? You can simplify. You can simplify. This is 320, right? 320. Then 320 minus 163 means 157, right? So this is 157e. So E is here. E equals, are they asking approximate values? Yeah, only the approximate values are asked. Then this is 150 over 157. Get the approximate value. Zero 0.95 comes. 0.95 comes. Then there is 0.95 centimeters. 0.95. Then uh, velocity of sound through air, right? Velocity of sound through air can be taken by any of these equations, right? I'll be choosing 2. From 2, V equals 163 times 4, 50 plus. Now E is 0.95, 0.95, but that is in centimeters. Convert this to meters, 10 to the power minus 2, right? Okay. A simplification, 163 4 50.95 10 to the power minus 2. 163 times 4. It comes to 332. It comes to 332. Right? Then what are the answers? 0.95 and 332. 0.95 and 332. Answer 2. For 18, answer 2. Right? Take it down. Take it down. Right? This is a common pattern question, a common type question. Take it down. Take down. Write down. Sorry, 19. Two horns, each frequency is 100 hertz, fixed at two ends of a 1 meter long bar. Right. Two horns, each frequency is 100 hertz, fixed at two ends of a 1 meter long bar. The bar rotates in an axis perpendicular to the bar at its center of gravity. Is there a lag in the stream? So is there a lag in the stream? Can you hear me properly? Let me check. Okay. Right. 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 So in 19, one data is not printed properly in the question. Right. It should be um, 20 RADS minus 1. 20 RADS minus 1. Yeah, it should be 20. That is not properly printed there. So make this correction, please. It should be corrected like this. Two horns, each frequency is 100 Hertz, fixed at two ends of a 1 meter long bar. The bar rotates in an axis perpendicular to the bar at, at 20 RADS minus 1. At 20 RADS minus 1. This is given. At 20 RADS minus 1. Right? Then from that you can determine the velocity, no? You can determine the velocity because we know V equals R omega, right? Then R is 1 meter long bar, so R is 0.5, half, and omega is 20, which means V equals 10 ms minus 1. V equals 10 ms minus 1, right? V equals 10 ms minus 1. Then now you can find minimum and maximum values of the apparent frequency heard by the person. If the velocity is exactly towards that person, he will hear the maximum frequency. If the velocity is exactly away from the person, he will hear the minimum frequency, right? Then we know f dash can be written as here it should be observer. Velocity of sound through air with respect to observer. This is velocity of sound through air with respect to observer over this is velocity of sound through air with respect to source into real frequency, actual frequency, right? Then let's say f dash 1. Now here there will be a velocity of 10 ms minus 1, and here there will be a velocity of 10 ms minus 1, and the observer is at rest. Observer is at rest, right? So if the observer is at rest, there is no relative velocity for the observer, then only the sound velocity comes, that is 330. And about the source is moving, then when it is moving towards the observer, will be 330 minus 10 into actual frequency 100, right? So from here 330 over 320 times 100 comes, right? 1 0 to 0 cancels, right? Then what's the value here? 3300 over 32, right? 3300 over 32. We'll keep it as that and going to do the rest of the simplification, right? Let me erase this part. You can hear me clearly, right? Okay, okay. Right. Some lagging is going on anyways, right? Then if I need the other frequency, let's say if dash 2, right, that will be 330 over 330 plus 10 into 100, right? When the speaker is away from the observer, when the speaker is away from the observer, right? Then here this comes as 330 over 340 times 100, right? On 0 to 0 cancels. Then this value is f2 dash, this value is 3300 over 34, right? Then the frequency of beats, right? Frequency of beats means difference of these frequencies, right? Delta f. Delta f is, what's the higher value? Higher value is this, right? Then that is this thing minus this, right? This can be taken out. Then 1 over 32 minus 1 over 34. It seems an approximate value is coming, right? It seems an approximate value is coming. This is this one. This is 32 times 34. And here 2 comes, right? Then 2 times 16. Simplify. Delta F equals 3300 over that thing. 3300 over 16 times 34. 6.06. Right? So this comes to 6.06, which means 6 hertz. 6 hertz. 6 is given answer 2 for 19. Answer 2. One second. I'm still checking whether the live is lagging. I'm still checking whether the live is lagging. Right? It seems it's fine. Right? It seems it's fine. Okay, let's see. Right, 6. For this one, answer 6. 20. Okay, the diagram shows waveforms of 4 waves. Which statement in the table given below is true? Right. Wave with high pitch. Pitch depends on what? Pitch depends on frequency. Pitch and frequency. Pitch. Pitch of a wave depends on frequency. Pitch of a wave depends on frequency. Right? Then high pitch means it should be the wave with high frequency. Right? Got the point? High pitch means high frequency. Frequency is number of vibrations per second. Right? Frequency of a wave is number of vibrations per second. Right? Now, clearly we can see highest number of vibrations per second is in C. Right? So, therefore, the wave with highest pitch is C. Wave with highest pitch is C. Right? So, highest pitch is C. Second one, wave with high loudness. Loudness depends on what? Amplitude. Right, now under waves, we discuss these properties. On frequency, pitch depends on frequency, and loudness depends on amplitude, and quality of sound. Quality of sound depends on the overtone or the wave pattern. Overtone or the wave pattern. Quality of sound depends on the wave pattern or the shape of the wave. Right? Those three are the things we discussed there. Wave with high loudness is then highest amplitude, A. Highest amplitude is for A. Because loudness is on amplitude. Right? That is A. That is A. Two waves for study the quality of sound. I told you. For quality of sound, right? The pattern or the overtone. Quality of sound with harmonic overtone. This depends on overtone, harmony, or pattern of wave. Right? So therefore, to study quality of sound, B and D are in the same pattern. B and D. So it should be B and D. Should be B and D. Right? Then what's the answer? Highest pitch is C. C and then A and B and D. Answer 3, right? Yeah, for 20, answer 3. Right? Okay. Right, 21. 21. A prism with refracting angle 30 degrees and made by a material of refractive index. There's another typo again. Refractive index root 2. It should be. Please make this correction. Otherwise, question cannot be done. Refractive index root 2. Right? So repeating again, it should be corrected as a prism with refracting angle 30 and made by material of refractive index root 2 is silvered on one refractive surface. Right? What is the incident angle of a light ray falls on other surface and travels back along the same path after refraction. Okay. So please make the correction. Now today's paper there are few more typos because in this week the typist was very busy and I got the paper with a like quick call. So therefore he was also busy and that was the thing. I think that's why there are a few mistakes and from my side also I was also busy. So therefore I couldn't get even a time to cross check the paper this week. So I can see there are a few more typos, right? But they are manageable. They are manageable. Right, okay. Then first try to identify how this prism is. So refraction angle is 30. And one surface is silvered. Let's say this is silvered. This surface is silvered. One surface is silvered. Right? Silvered means now it acts as a mirror. It acts as a mirror. Now the ray travels back at the same path now, through the same path now. That's a good point. That's a good point. Because if the ray travels back through the same path, it should be fallen perpendicular to silvered surface because silvered surface acts as a mirror. Right? That is my argument. So it should be fallen perpendicular to the silvered surface. Then if you draw the normal here, right? Then this is how the light ray should be traveled. Is that clear? Because it should be normal to the silvered surface to come back along the same path. If there is normally incident, then it comes along the same path. Then again, it comes along the same path with the alternative property of light. Right? If one direction, if light travels with same angles, it can travel in the exact opposite direction as well. That is called alternative property of light. So with that, this travels. With that, this travels. Right? So first thing, this is what you need to identify. Okay, then if this is 30, this angle should be 60, which means this is again 30, no? Right. Refractive index is √2. Then what we need is incident angle. I is here. So use Snell's law here. Right? N1 sin I equals N2 sin R. N1 is 1 into sin I equals N2 √2 sin R is sin 30 half. Right? Sin 30 half. Then √2 to 2 cancels. √2. Which means sin I equals 1 over √2. Which means I equals 45. I equals 45. Yeah. 45 is given answer to 21. Answer to. Right? Twenty-two is also from optics. 22 is also from optics. 22. That is also from optics. Right. A plane mirror is placed on the floor of a container with a liquid of refractive index n. A point object P is placed above the mirror at height h. An observer directly at O above P at O can see. An observer O, it should be directly above the point P, can see two images of P. The distance between these two images is okay. Okay. And this is a mirror now. This surface is a mirror. P is at h distance above. P is at h distance above. Then we know this is real P. This is the object P. The image due to mirror is at the same distance here, at same edge. let's say this is I1, right? And what's the second image here? Second image means if the person is looking through this line, we know due to refraction of water surface here, due to refraction, he will see an uplifted image, which means a displaced image due to apparent depth and real depth phenomena. Apparent depth and real depth. Right? And apparent depth is pain. Apparent depth. Real depth right? So he will see an apparent depth. If this is here, that image will be somewhere here. Let's say I2. And this is called the apparent displacement. D. This is called the apparent displacement. Right? So we can find the apparent displacement at once using the equation of apparent displacement. Right? We know apparent displacement can be written as T times 1 minus N2 over N1. Right? Apparent displacement T, thickness of medium, N2, refractive index of the medium where I is kept, N1, refractive index of the medium where the object is. Right? Apply that equation. Then D can be determined as thickness of the medium. Thickness of the medium. Wait. A plane mirror is placed on a right. An object P is placed on a mirror at height h. Right. And height is not given, right? Then probably it will cancel. We'll see. Right? Probably it will cancel. We'll see. Let's consider the height from here to here as. Let's consider the height from here to here as x. Right? Then thickness of the medium which matters for this is x. Right? X. 1 minus. This is 1 over n because I is at air 1. This is given as n. 1 over n. Right. So D is here. D is here. Okay. D is here. Then final question is the distance between these two images is correct. One image is here, no? One image is here. The second image is here. So this is the distance we are interested about. Right? Then using the diagram, I can write that distance as using the diagram, we can write that distance as this is wait. No. The question is not about these two images. Can see two images of PR, right? I got it. Which means the other image is there is another image to be determined. Third image. Right? The other image is the image that person sees with respect to person, which means this image is also seen by the person as an displaced image. Right? With respect to person, the question is asked. Then the two images the person sees is the apparently displaced actual object and apparently displaced image of the mirror. Right? This will be displaced. Right? So let's say this image is seen by the person somewhere here, I3, and this displacement is, let's say, D2. We make a D1. This is D1 now. Right? Now D2 can be determined again. That's a good question. Right? You have to understand. Right? Now D2 can be determined again. D2 equals thickness of this medium now is the total thickness is x plus h. Again 1 minus 1 over n. Okay. D2 is also known. Okay. Now what we need is the distance between these two. What we need is the distance between these two images. Right? Then that distance is, we can write that distance as, see, that's a good question. Let's say that distance is capital D. So we can write that capital D as, right? Then we know this part is 2h, and this small part can be written as 2h minus d2. No? It can be written as 2h minus d2 plus, right? This small part is 2h minus d2. Part again, and this is d1 plus d1. Okay, then these answers are already proved. 2h minus d2. d2 is here, right? X plus h. 1 minus 1 over n. 1 minus 1 over n plus d1. d1 is here. X times 1 minus 1 over n. Right. Then d equals 2h. Now from these two, I can see 1 minus 1 over n is common. No? We can take it out. So if I take minus 1 minus 1 over n out, from here what remains is x plus h. From here x plus h remains. And from here minus x remains. See, x cancels. X cancels. Clear? Because I can take 1 minus 1 over n out. I got minus 1 minus 1 over n out. Then here x plus h remains. Here since minus is taken, minus x remains. Right? Then x2 minus x cancels. D equals 2h minus here 1 comes. Minus 1. Then plus 1 over n. Right? Oh, wait. Let's simplify this way. This is minus 1 minus 1 over n. And here only h remains, no? Yeah. Only h remains. Only h remains. What are the given answers? Okay, answers are there with 1 as well. Okay, let's see. Okay, then simplify this thing. 2h. From here, minus h comes, minus h. And from here, plus h over n. Plus h over n. Right? 2h minus h is h. Then this is h plus h over n. Take h out. Then 1 plus 1 over n. H times 1 plus 1 over n. H times 1 plus 1 over n. Answer is the answer 4. That's a good question. For 22, answer 4. See, that's a good one. That's a good one. Right? You have to have an idea about all 3 images formed here, and persons is only 2 images, right? These 2 are the apparently displaced actual object and apparently displaced image of the mirror, right? That is how the answer comes. Right, take it down. That's a good one. That's a good one. Not the usual or the common type of apparent displacement question. This with a small thinking, I think in good thinking. Right, 23. That is also from optics. 23. It says an underwater diver in a pond want to send a message to a person on the bank of the pond by using his torch. For this, he should direct the light vertically up. Right. Now, the person is in a pond, something like this. The person is inside a pond. So we know if a light ray comes from the pond like this, see what happens. If a light ray comes from the pond like this is dense to rare. Then this bends away from the normal. This bends away from the normal. Bends away. Now the person is at the bank, right? Person is at the bank of the pond. Then he should, now we know there's a bending, no? Bank should be somewhere there, right? Bank should be somewhere there. First one is vertical upwards, no? If there is vertical upwards, the angle of incidence is going to be 0. If angle of incidence is 0, no refraction happens. This is what happens if there is vertical. This is what happens if there is vertical, no refraction. If there is vertical, so therefore it is not going to work. Vertically is not going to work. Second one, direct the light horizontally. It is anyway not going to work because then it is not going to go into the air medium. That is not going to go into the air medium. Third one, direct the light with the angle less than critical angle, make with vertical. That is correct. Because at the critical angle, we know it travels through the surface. You know what the critical angle means, no? Then for a higher angle like critical angle like this is what happens. For the critical angle, then it should be an angle less than critical angle. It should be an angle less than critical angle. 3 is correct. We'll check 4 and 5 as well. Direct the light with an angle larger than the critical angle. No, if the angle is larger than critical angle, what happens is it will be total internal reflection. It will be total internal reflection. The facts are not enough. No, that's not the case. Answer 3. 23, 3. 24. 24. A straight line with the length of L was drawn on the objective piece of an astronomical telescope in normal adjustment. A real image of line is formed in the eyepiece and its length is L. The magnifying power of telescope is. Okay. Now in the astronomical telescope, this is how the lenses are. See, now it is the axis. Now this is how the lenses are, no? Objective piece and eyepiece, right? Let's say f4 and fp, focal length. Now, we know basically this is how light rays travel here. Basically, this is how light rays travel here. In the telescope, if they are parallel light rays, this is how it travels. If they are parallel light rays, right? Now here, it says here, a line is drawn. A line is drawn. And that line is imaged here. The line is imaged here. A line is drawn like this here. And that line is imaged here. Okay. So we know the distance from here to here is focal length, no, f4. Distance from here to here is fe. Focal length of eyepiece. Now, we can see these angles are same, no? Right? So write tan alpha. Tan alpha equals tan alpha. Right? Then this is given as capital L. And this length is given as simple L. Tan alpha can be written as capital L over f4. And from this triangle, tan alpha can be written as simple L over fe. Right? Then magnification is asked. So we know magnification of an astronomical telescope is equal to f over fe. Right? That is a proved equation. Magnification of an astronomical telescope equals to f4 over fe. Magnification equals to f4 over fe. Right? So we know magnification of astronomical telescope is f4 over fe. So therefore, I'm going to create f4 over fe here. create FO of F, cross multiply this thing. Then here FO of FE can be written as capital L over simple L. No? So this is actually the magnification, which means magnification equals capital L over simple L. This is the answer. Capital L over simple L. Answer 1. For 24, answer 1. Right? 25. 25. If the mean depth of C is 4 times 10 to the power minus 3, 10 to the power 3 meters, and the coefficient of volume expansion of sea water is, again, there are something missing. It should be 2.07 times 10 to the power minus 4. Right? Make the correction. It should be 2.07 times 10 to the power minus 4 per degree Celsius. Right? 2.07 times 10 to the power minus 4. 2.07 times 10 to the power minus 4. What is how much the sea level is raised when the temperature increases by 1 degree Celsius? Okay. Then, if only a height is asked, right? If only a height is asked, don't use volume expansivity, use linear expansivity, because height is a linear parameter. Use linear expansivity. So we know delta L equals L1 alpha theta. Right? Then we need delta L. L1 is the original value, original depth. L1 is the original depth, 4 times 10 to the power 3. 4 times 10 to the power 3. And alpha, we know gamma equals 3 alpha, right? Right? Gamma equals 3 alpha. Then gamma is given, no? Volume expansion in 2.07. Make a trivialing down 2.07 into the minus 4 over 3. Theta is 1. Simplify this. Right? So this should cancel, no? Because this is 180 and 27. Sorry, cancel, no? It should be 69. 207 means 69. Then this is 4. 10 to the power 3 and 10 to the power minus 4 means 10 to the power minus 1. And here 207 is 69. Then 20.7 is 6.9. Then this should be 0.69. What's that? 4 times 0.69. 70 times 4 is 28. 276, which means 2.76, right? 0.276. So that is 0.276 meters, right? Approximate answer is given, then 0.3. 0.27, 0.3 meters. 0.3 meters. 25, 1. Right? Expansion. Right? 26. The diagram shows the variation of pressure against the density of ideal gas at 3 different temperatures. According to it, the correct choice is right. The variation is between P and rho. Variation is between P and rho. P and rho. Then I'm going to check the gradient. So we know Pm equals rho RT. No, this is a proved equation. Pm equals rho RT. Is proving from here. We know PV equals nRT. PV equals nRT. Then PV equals N can be written as M over M RT. Right? cross multiply this, Pm equals M over V RT. M over V is rho, which means Pm equals rho RT. This is the proved equation. Pm equals rho RT. Gradient here is P over rho. So I'm going to create the gradient P over rho. P over rho is what? RT over M. Right? Which means gradient here represents RT over M. Gradient here represents RT over M. Then higher gradient means then it should be a higher temperature because R is a constant, M is a constant. Higher gradient means higher temperature. Highest gradient of the given curves are T1. T1 is the highest gradient, then it should be the highest temperature, which means T1 is greater than T2 is greater than T3. Answer 1 for 26. Answer 1. Right. Give me 1 second. Give me 1 second. One second. Okay, then 27. 27. Temperatures of three liquids A, B, and C are 10, 20, and 30. Three liquids. Okay. Something like this. There are three liquids A, B, C liquids. There are the right? 10, 20, and 30. 10, 20, and 30. Right? Respectively. When the equal masses of A and B are mixed, the final temperature is 17. A hint is given. Equal masses of A and B are mixed. Equal masses. Right? Equal masses of A and B are mixed. Then we are going to mix these two first. These two first. Right? Then we know heat absorbed by what's the common temperature? 17. 17, which means heat absorbed by A is equal to heat liberated by B. If temperature decreases of a system, which means it liberates heat. If temperature is increased by the system, which means it absorbs heat. Right? Then heat absorbed by A equals heat liberates by B. Q equals ms theta. That's a common equation. Q equals ms theta. Same mass. Let's say this is SA. Right? Then theta should be, now this has gone to 17, which means theta is 7. For theta B, for QB, M, SB, and 20 to 17 means 3. M to M cancels. Okay, we have a relationship between specific heat capacities of these two as 7 SA equals 3 SB. One equation is 7 SA equals 3 SB. 7 SA equals 3 SB. Right? Then I'll erase this part. Then these two are mixed now. These two are mixed, right? A and B, sorry, B and C, right? And equal masses of B and C, the final temperature is 28. Okay. So when these two are mixed, final temperature is at 28. Then heat absorbed by B equals heat liberates by C. MSB 2028 temperature difference is 8. Then MSC 30 to 28 temperature difference is just 2. Right? M to M cancels, 2 and 8 cancels, 4. From here it comes 4SB equals SC. 4SB equals SC. Right. Then the question is, what is the final temperature after mix the equal masses of A and C? Sorry, A and C. A and C. If A and C are mixed, okay. See. Okay, if A and C are mixed, right? Again, same argument, QA equals QC, right? Then Q can be written as MS theta, then MSA. Now we don't know the final temperature, but 10 and 30, right? Two objects, two liquids at 10 and 30 are mixed. Always, if two objects or two liquids or anything are mixed, always the equilibrium temperature is going to be a value in between 10 and 30 mixed. If 10 and 30 are mixed, the temperature at equilibrium is going to be a value in between 10 and 30. Right? That idea you have to have. So therefore, it is definitely greater than 10. Right? Which means this is theta minus 10 temperature difference. And here M SC, and that is less than 30. So this should be 30 minus theta. In correct direction, you have to write these two. In the correct direction. Right? In the correct direction, you have to write these two. Okay? Then simplify. M to M cancels. Right? See what remains, SA times theta minus 10 equals SC times 30 minus theta. Right. Now, to cancel them off, now I can see we have a relationship between A and B, SA and SB. Here SB and SC, which means we can convert both of them to B, no? Then with that B can be cancelled. Right? Having that idea, I'm going to write SA in terms of SB like this. SA can be written as 3SB over 7. This can be written as 3SB over 7. Then theta minus 10 equals SC. SC can be written as 4SB, no? Then this is 4SB. 30 minus theta. See, SB to SB cancels. That's all. Right? Cross multiply this thing. That's all it cancels, right? Yeah, that's all it cancels. Cross multiply. Then here 3 times theta minus 10, and here 28 times 30 minus theta. Right? This is 3 theta minus 30 equals, what comes here? 28 times 30. 28 times 30 means 30 times 30 is 900. Then 840. Ne? 840 minus 28 theta. Take this to the other side. Then it becomes 31 theta. equals 870. Theta equals 870 over 31. This has to be checked. 870 over 31. 28.06. It comes to 28.06. 28.06. So which means that is 28 again. 28 again, answer 5. For 27, answer 5. Right? Okay. Take it down. Take it down. Question 28. When a drop of water is put onto an iron sheet with high temperature, before evaporate the water, it converts into a spherical drop of water. The reason for this is, so we know water is spherical in air mediums, right? In air mediums, water is spherical. Raindrops, right? As an example, raindrops, rain droplets, right? They are spherical. So in air mediums, it is spherical. The reason is intermolecular forces between water and water, that is actually the cohesive force, is greater than the adhesive force between water and air. Right? The reason is asked. Layer of water vapor formed between the drop of water and the sheet prevent the heat conduction. That is actually correct. That is actually correct, because when that water vapor layer is formed, there is vapor, no? Vapor means air. Then water drop is spherical. Right? We'll see the other reasons as well. The boiling point of water increase. No. Boiling point is a constant. Boiling point is a constant. And it only changes with what? Pressure. It only changes with pressure. Pressure එක වෙනස් කරොත් විතරයි boiling point එක වෙනස් කරන්න පුළුවන්. Right? Altitude එක වෙනස් වුණොත් හරි, because pressure changes when altitude changes. නැත්තම් බෑ. It's a constant for a under given conditions. 3. The temperature drop at the place where the water drop is put. No, because that is at a high temperature and only a water drop is put. Right? So it is not going to change the temperature there. Heated sheet is a poor conductor. No, heated sheet is a good conductor. Both 1 and 2 are correct. No, only 1. 1 is correct. For 28, answer 1. Right? For 28, answer 1. 29. The W work has done by a certain ideal gas sample with U1 internal energy is allowed to expand adiabatically. Adiabatic means delta Q is 0. Right? We have main two types of processes, adiabatic and isothermal. Adiabatic means delta Q 0. Isothermal means delta U 0. Right? So then apply the first law of thermodynamics. First law of thermodynamics, delta Q equals delta U plus delta W. Delta Q equals delta U plus delta W. Right? Then since there is adiabatic, delta Q is 0. Since there is adiabatic, delta Q is 0. Delta U. Right? So then let's assume the final internal energy as U dash. Right? Then delta U should be final minus initial, U dash minus U1 plus W. A work W is done. There is an adiabatic expansion, no? Expand adiabatically. Adiabatic expansion. In expansion, work is plus. In expansions, work is plus. Right? Because work is P delta V. Right? Work can be written as P delta V. Work is plus. So that W. Right? Then subject W. W can be written as U1 minus U dash. Right? Yeah, W is U1 minus U dash. I will consider this as equation 1. And then to this, Q amount of heat is supplied so that supplied to the gas under should be constant, not content, constant, under constant volume and pressure. Under constant volume and pressure means at constant volume, again you can see del W is going to be 0, right? Constant volume means del W is 0. Pressure at same at initial pressure. If the new internal energy of the gas is U2, the internal energy increase of the sample is okay. Then if we apply the first law again, for the second case, delta Q equals delta U plus delta W again. But in this case, delta W is 0. Right? Then Q equals, given means plus, Q equals, so let's say finally is U2, no? U2 minus U dash. U2 minus U dash. Right? It is supplied. Supplied means plus. Okay. Then we need U2 minus U1. Then what you can do to get U2 minus U1? Subtract these two. Subtract these two. Let's say this is 2. Then 2 minus 1. 2 minus 1. Then Q minus W. Q minus W. And from here, U2 minus U dash. And here, minus U1 plus U dash. These two cancels. Then Q minus W equals U2 minus U1. This is the increase of internal energy. So that is Q minus W. Answer is 4. 429, answer 4. Right, 429, answer 4. $30. Two copper spheres, surface of one is darkened and the other is polished, heated of 300 kelvins and hung inside a vacuum chamber, maintained its temperature at 273 kelvins. Which statement given below is true? Right. One is darkened and the other one is polished. 30, right? Okay, one is darkened and the other one is polished, right? So we know, according to Newton's law of cooling, Q over T is EA theta minus theta R, right? E is what? Very popular one. Q over T is EA theta minus theta R. Emissivity, or that is called coefficient of emissivity. This is called coefficient of emissivity. Coefficient of emissivity. Coefficient of emissivity. Right? For black and rough surfaces, E is high. The theory is this. Right? For black and rough surfaces, E is high. And for white and smooth surfaces, white smooth, E is low. White smooth, E is low. Right. Now let's go to the statements. Initially, heat increase rate of two spheres are same. No, because anyway there is no heat increase there. Heat increase kiyane komat karadi. Right? Because it should be a decrease. It is going to cool down. Objects are at 300, whereas the room is at 273. That is not an increase anyway. Initial temperature of darkened sphere is drop and temperature of the other increases. No, both decreases. Newton's law of cooling. Both decreases. Right? Both of them decreases. both of them decreases. 3. Initially, temperature of darkened sphere is increases and dropped in the other one. Cutoff dropped there in the third one. It should be corrected like this. Initially, temperature of darkened sphere is dropped. Cutoff is dropped. It should be initially temperature of darkened sphere increases and dropped in the other sphere. No, both drops. I told you, both drops. At the end, value of temperature of two spheres and chamber are same. That is correct, because any cooling curve ends at the room temperature. This is a cooling curve, theta and T. This is called a cooling curve, and always cooling curve ends at the room temperature. After decreasing temperature, cooling curve ends at room temperature. Then both are coming to the room temperature. It is correct. At the end, value of temperature of two spheres are same and the chamber has different. No, all are same. Answer is 4. For 30, answer 4. Right? 31. It should be a particle, not a practical. A particle. 31. A particle. Particle. Right? Particle. Okay. 31. A particle moved from point X to point Y in a gravitational field. Okay. In a gravitational field. Moved from point X to point Y in a gravitational field. Right. First one, change of gravitational potential is independent from the path between X and Y. Correct. Why? Gravitational potential is, this is the equation. Gravitational potential is minus Gm over potential of minus Gm over X. Gravitational potential is minus Gm over X. Right? So it changes, independent of the path of the motion. Right? So let's say the mass is somewhere here. Let's say the mass is somewhere here and it moves from X to Y like this. So what matters is these two distances only. What matters is these two distances only. So that is irrespective of the path. That is correct. A is correct. So A is correct. B. The kinetic energy change of the particle at X and Y is equal to potential energy change. Yes, that is actually the conservation of energy. Conservation of energy. Conservation of energy. So that is correct. C. The potential energy change is independent from the mass of the particle. Potential energy change. Potential energy, no, not the potential. Potential energy means this. Potential energy is minus Gm m over X. Right? Potential energy is minus Gm m over X. Potential is Gm over X. Potential energy is Gm m over X minus. Right? The potential energy change is independent of the mass. No, because mass inverse. That is wrong. So only A and B. Answer 3. Only A and B. 31. Answer 3. For 31, answer 3. Fine. (32) Water drops with a radius of simple r fall into a spherical metal container of radius capital R from a container of water with potential maintained at V. The metal container is placed on an insulated sheet. The potential of the sphere after filled with water is. Right. Potential of the sphere after filled with water. Okay. Right. Now, initially, that's question 32. Initially, now these kind of ones are falling and their potential is at V. The potential is at V. Right. So let's assume charge of this one drop as Q. Charge of this one drop as Q. Then we know potential can be written as 1 over 4 pi epsilon naught Q over R. No, this is a constant, so I will refer that as K. Then this is KQ over R. Right? This is my equation 1. And we know another sphere of radius capital R is going to be filled. Then we'll have to know how many such droplets are needed to fill that sphere of radius R. Because if one droplet carries a charge Q, let's say 10 droplets are needed, then it carries 10 Q to that sphere. Got the point? If charge of one droplet is Q, let's say we need 10 drops to fill that large sphere, then the total charge there in the sphere will be 10 Q. If we need 20 drops, then it will be 20 Q. So therefore, we don't know what the number is. You have to have a relationship, right? Then we can equate volumes. Because when that is filled, we know volume of these two has to be equal. Then here volume can be written as using small spheres 4 over 3 pi simple r cube. We don't know how many are needed. Let's say n equals, this is 4 over 3 pi capital R cube. Right? 4 over 3 to 5 2, 4 over 3 5 cancels. See what comes in simple R cube equals capital R cube. This is the number of droplets needed, R cube over simple R cube. Right. Then what is the question? Question is the potential of the sphere after filled with water is. Potential of the sphere after filled with water is. Okay. Then again we have only this equation to write the potential. Right. So write the potential. Write the potential. 1 second. Write the potential. Then again V can be written as K. Now here n number of small droplets are there, then NQ over R. NQ over R. Okay. Then let's say this V dash, V dash. Okay. What you can do? Either you can substitute for KQ, right? KQ will substitute karna puluwan. I can write this way, no? V dash equals, this is N over R. N over R times KQ. Isn't it? N over R times KQ. KQ is VR. Okay? From here, VR equals KQ. Then V dash equals N over R. And KQ is V simple R. N is not given, we have to substitute. So V dash equals, now here N is capital R cube over simple R cube, and here VR over R remains, right? 1 R2, this cancels R squared, this R2, 1 R cancels R squared. So this is R squared V over simple R squared. Capital R squared V over simple R squared. Answer 4, 32, answer 4. 32, 4. For 32, answer 4. Thirty-three. Radii of two concentric spherical conductors that shown in the diagram are A and B. Right. A and B, and this is grounded. And here Q is given, right? If the inner sphere is Earth and charge Q is given to the outer sphere, the charge on the surface of two spheres are. right? So we are to determine the charge here. So let's assume this charge as simple Q, right? So charge or the before charge, we can write the potential at the internal surface. Potential at the internal surface can be written as potential is written as K Q over no, right? Then potential at the internal surface is 1 over 4 pi epsilon naught, right? Due to simple Q, potential at that same surface is Q over A, right? And due to capital Q, potential at the surface inside is equal to the potential at the outer surface, that is plus Q over B. Since this is grounded, this potential is 0. Since this is grounded, this potential is 0, right? Potential at this surface can be written as Q over A using simple Q inside, and potential at this surface due to capital Q can be written as, right? There's a theory we have proved, and we are proving in electric fields as potential at the internal point is also equal to potential at the outer surface of the sphere, right? So therefore, that is Q over B, which means this is 0. So Q over A is going to be plus Q over B equals 0. Take this to the other side. Then Q over A equals minus capital Q over B. So simple Q equals minus QA over B minus QA over B. Minus QA over B means answer 1. So 33, 1. Ready? 4. From the 3 unique metal plate system shown in the diagram, the upper and the lower plates are earth, and Q charge is given to the middle plate. Okay. The potential of the middle plate is, right? So this is the given diagram. Three, two, one. This is grounded. 2D. And one is grounded B. One is also grounded. Right. The potential of the middle plate is, right? Q is given to the middle plate. Okay, Q is given to the middle plate. Right. Then here we have a Q. Here we have a Q. Okay. If we need to write a potential, so what are the ways of writing a potential? When a plate is given, when plates are given, we have only one equation. That is E equals delta V over D, no? Right? E equals delta V over D. Okay. Then, yes, let's write it this way. We know this equation from electric fields. E can be written as delta V over D. In addition, again, we know, in addition, E can be written as, E can be expanded as, using phi, we can do an expansion, no? We know phi equals EA. Phi equals EA. Right? That is easier. That is easier. We can find E. And we know phi can be written as Q over epsilon naught. Right? Gauss law. Gauss law. Phi can be written as Q over epsilon naught equals EA. Okay. Which means E is known. So E is what? Q over epsilon naught A. Right? E එක හරි. E එක හරි. එහෙනම් මෙතෙන්ට ආව නම් හරි. Then you can apply to either of the plates, right? Yes. Then E is Q over epsilon naught A equals delta V. If I use these two, now I have proved this two. Now this is important. Yes. Now we have proved this two. The same distance. Then if you are using it for D, we have to use that. You can remember E. The E is like this. From here to here, there is EX. From here to here, there is EX. Right? Right. Then, if I use the upper plate, let's assume this is V, then V minus 0 over D. Right? V minus 0 over D. Then, from that side, V comes as V equals what? QD over epsilon naught A, right? QD over epsilon naught A. Give me 1 second. Okay, then from this side, let's say the potential is V2. Yes. Correct. One second. T is determined phi Q epsilon naught Q. We need potential at the middle point, right? Yeah, potential at the middle plate. Potential at the middle plate, then it directly comes. Right? So this is the element. Right? Potential විතරයිනේ. So let's say V. That's it. V. Then V is QD over epsilon naught A. QD over epsilon naught A, answer 2. For 34, answer 2. For 34, answer 2. Right? Then 35. The table given below represents some Rn. It should be L, not I. It should be L. Make the correction L. Some Rn L readings. L should be in centimeters. Should be like this. It should be L in centimeters. Make that correction on the table as well. Right? L. Balance length. L. Right? Balance length. Make it L. That should be the balance length. Right? RNL readings for meter bridge scale shown in the diagram. Right? Which pair of the readings in the table is not get correctly? Okay, that's a different question from the meter bridge. Right? Different question. So we know principle of meter bridge is R over L equals principle of meter bridge. R1 over L equals R2 over 100 minus L. This is the principle of meter bridge. Now, if I apply this to this given scenario, R over L equals X over 100 minus L, right? Then it should be R over L equals X over 100 minus L. R over L equals X over 100 minus L, right? Now, we need to check some pairs of values, right? X is going to be same resistor is used. So therefore, if I subject X, see, if I subject X, what comes is R times 100 minus L over R. Sorry, R times 100 minus L over L. Right? Now, if I apply those given values for these three, then we can get some idea about the value of X now. Because this is about the same experiment. And these are some instances where we have got different values for the experiment. Right? This is an instance where you have got different values for the experiment. Right? And apply කරලා බලන්න පුළුවන්. First scenario එක apply කරන්න. R is 1000. Right? First scenario එක apply කරනවා. What are scenarios 1, 2, 3, 4? 1, 2, 3, 4. We have 4 scenarios. 1, 2, 3, 4. Right? So apply first scenario. R is 1000. Then this comes as 1000 times. L is 60. Then 100 minus L is 40 over 60. Value value. What's the value? Roughly 0 to 0 cancels. 2 times 2, 3, which means 1000 over 3 is 330. So 666. Which means X is 666 ohms. X is 666 ohms. Apply the second instance. Second instance, R is 100. R is 100. Then it should be 100 times L is 100 minus 13, 87. 87 over 13. Right? Simplify 100 times 87 over 13. 100 times 87 over 13. It is 669. It is 669. 669 ohms. Then third instance, 10 and 1.5. Then this comes to 10 times. 1.5 means this is 98.5. 100 minus L. 1.5. Right. Nothing cancels. Then this is 985 over 1.5. No? What's the value? 985 over 1.5 means 3 over 2. 990 කියන එක divide වෙනවනේ. ඔන්න ඒකෙන් ටක් ගාලා බලන්න පුළුවන් 330. This is around 660. This is around 660. 990 divide වුණානේ. So this is also around 660. Right? And next one, 1 and 1. 1 times 99 over 1, which means 99 ohms. Can you see? Now, value of X is drastically different in this scenario. Value of X is drastically different in this scenario. These are at least around 660, something like that. But here 99, drastically different. Then this has to be a wrong pair. This has to be a wrong pair. Got it? Then answer is 4. Answer 4. For 35, answer 4. 35, answer 4. 35, answer 4. Right? That's a kind of a different question. A little bit different question. right? Okay. For remaining 15 questions now, we are still managed to discuss only 35 questions today with the length of the questions and all that, right? And we started from 1, then 1 to 35 questions are discussed, right? For remaining 15 questions, I'll be sending you the answers along with the marking scheme, right? Marking scheme of this paper can be get by the Thursday, right? With the next paper, right? With the next paper, you can get the marking scheme by Thursday, and it will be available under week 2 in the website, right? Under week 2 October in the website, right? Okay, then yeah, since it's 10:20 now, I'll be winding up the class here. Any questions before winding up? Any questions? Anything to clarify? Anything to know before winding up? Anything? Is it all clear up to this point? Is it all clear up to this point? Or is there anything to clarify? Right. Okay, then if there's no any questions, we'll be winding up the class for today, right? And next day you'll be writing, next week you'll be writing an essay paper, right? And we'll be discussing that essay paper. And I think you have got all the marking scheme for the all papers up to this point. For the last week paper also, I have uploaded the marking scheme under week 1 October. You can get the marking scheme of the last one, right? So as usual, now all the markings will be updated and uploaded to the website, right? So you can get this also by next Thursday with the next paper, right? Okay then, so if there's no any questions, we'll be winding up, right? And the ones who are watching the recording, who are not in the live class, still if you got any questions about these questions I discussed here, feel free to drop me a message and clarify them out, because you are just now 4 weeks ahead of the exam, right? Just 4, right? It's like 4 weeks and 6 days now, right? It's like 4 weeks and 6 days, right? Okay, just 4, right? 5. Okay. If you got any questions, you can drop me a message to my WhatsApp class number, and get it clarified, right? Okay, then we'll be winding up. Then study hard, work hard, and stay safe these days, because you are very close to the exam now, just 4-5 weeks ahead of the exam. So stay safe, right? Good night and goodbye. Good night.